Hello everyone, you're welcome to Boy tutorial. The topic of today's video is designation and is the work example of fit, limit and tolerance I taught in part 1, and this is a part 2 of it. So if you are new to my channel, I would love you to subscribe and click the notification bell to get notified of my latest video, and I would love you to share this video to your friends that need it more because they will need it. Alright. A fit is designated as 45 H8 G6 50 H6 small h5 and 50 capital letter M or uppercase letter M6 small case letter M8. Right, so make sure you watch this video to the end. We are going to work on these three examples, so don't miss it out. Make sure you watch this video to the end. All right, now topic to cover, we are to find the value of the tolerance unit and the fundamental deviation for the hole and shaft. Then lastly, we are going to find the tolerance for hole and shaft. So before we go further, I would like to explain more about this symbol here, what they actually mean. All right, so I'll make use of this one to give the explanation. 45 cap letter H or uppercase letter H small case letter G6. Now what do they actually mean? This one here, this 45 means the basic size. The basic size dimension. Now for the basic size dimension, I would like you to go back to the part 1 to watch the part 1, because I explain more about this basic size, and there's a diagram I explain more about the feet, the clearance and other parts on hole and shaft. So I would love you to watch that part 1 of feet, limit and tolerance, the part 1. Then let's go further. Now for our H, this the uppercase letter H means means fundamental deviation for hole, and my 8 is an IT grade for my hole, while my G is my fundamental deviation for my shaft, and my 6 is my IT grade for my shaft. So this is my basic size dimension, and my H here is my fundamental deviation for my hole. My 8 is my IT grade for my hole, and my G is my small case letter G is my fundamental deviation for my shaft, and my 6 here next to the G is my IT grade for my shaft. So my hole is indicated with capital letters. It's always indicated with capital letters. While for my shaft, it's always indicated with lowercase letters. Alright, so that's the difference between them. So let's do some work examples for number 1. Now, solution. Let's start with 45 H8 G6. When solving this problem, we have basic formulas you need to come across. Now, number 1 basic formula is your I. Your I for the IT grade. Your I to have a basic formula which is 0.45, then multiply by your diameter 1/3 plus 0.001 multiplied by the diameter. So this is your formula for your I. Then another thing again, if you look at the chart on the screen, you will notice that 45 falls in between 30 to 50. So therefore, we are going to follow the step one by one. Therefore, what are you going to do? You square the 30, then multiply by the 50. That is square root of 30 multiplied by 50. Now, if you check this, you are going to have 38.73. Understand? So these are the steps. This one is step number 1. Then this step number 2. Then after you have done this, this is your diameter. This is your diameter. So your answer you get here is your D. So let me say D, comma D is equals to 38.73. So this is your D. Now, since this is your D, you have to insert your D into this. Let me call this equation 1. Understand? Now, I will insert my D into my equation 1. So my I is going to be 0.45 multiplied by 38.73 bracket 1/3 plus 0.00 multiplied by 38.73. So whatever you get here is your I. So my I is going to be equal to this one here. Gives me 1.5225 plus 0.03873. So by the time I add these two numbers together, my I is going to be equal to 1.56 microns, because your I is always on microns. It's always on microns, or you can convert it to mini microns, which is 0.00156 mm, which is in milli microns. So this is my first step, my second step. Now let's move to the next step. The next step, now we are going to find our fundamental deviation. Now, how is it going to be done? Now remember, our I is 0.00156. So that's for my I. Now, the next thing we need to do is to find our fundamental deviations. So our fundamental deviation for who? for O, remember we have 45. Remember we have 45 GH. So for our O, H here is our fundamental deviation. So if you check the charts on the screen, our H is equals to 0. So our fundamental deviation for O is what? 0. Our fundamental deviation for H is 0. Then for shaft, we have G. If you check on the screen, you will get this formula for G. G is equal to minus 2.5 D 0.34. So this is our D and our G. The formula for G. So our D is equal to 338.73. So we are going to install this our D into this G formula. So it's going to be G is equal to minus 2.5 brackets of 38.73 bracket close 0.34. So by the time you calculate all of this, we are going to have our G as minus 8.7 mm. So that's for that. Then the next step, this step 3. That is step 3. Then our next step, we are going to find IT grade. So our next step is the IT grade. This one is going to be step 4. This one is going to be step 4. So our IT grade for O is equals to what? IT grade 8. Remember, our IT grade for O is 8, and our IT grade for shaft is 6. So our IT grade for O is 8 here. Now for our IT grade for our O, we have IT grade 8, and if you check on the chart, it's 25i. So it's going to be 25 times 0.00156 for our I. This is our I, which is equals to 0.39 millimicrons. Then for the shaft, it's IT grade 6. So it's 10i on the chart. It's going to be 10 times 0.00156, which is equals to 0.0156 millimicrons. This is the diagram. Before we understand this diagram, let's go to the next problem here. For the O, our upper limit, which is this, our upper limit, which is the tolerance here, is going to be 45 plus 0.039. 45 is my basic size. Add together with my tolerance, I will have this. Remember, my 0.39, we got it from our IT grade. IT grade is used to find the tolerance, that is the main tolerance, while the fundamental deviation is used to find tolerance below the basic size. That is below the basic size if it's for the O, below the basic size. So for below the basic size is 0. That is our H was 0. Then for our, okay, let's go further. Lower limit is equals to 45 minus 0. Now this 0 here is our fundamental deviation for our H. Our H is 0. So is going to give us 45. It's used to find the tolerance below the basic size if it's for the hole. That is the fundamental deviation. Then for the shaft, our upper limit is equals 45 minus 8.7. That is our fundamental deviation below the basic size. Now, if you watch, there is 8.7 minus 8.7 because it's coming down. That is our G. Our G is equals to minus 8.7. So if you watch the chart, our G is below the basic line. That's why there's an allowance here. And once it's below the basic line, it's always negative. All right, so our upper limit for our shaft is 36.3, which is this 36.3, our upper limit. Then our lower limit, then we will now say 36.3 minus the tolerance. The tolerance is 0.0156, which is this one. The tolerance is same as the IT grade. So these are the tolerance. So once you take it away from 36.3, which is this upper limit here, we are going to have 36.28. So that is for the lower limit. Whatever you have here down to this side is the minimum size for our hole. And the minimum size for our hole is going to have 36.28. So from here to this place, which is our minimum size, is 36.28. Then our maximum size is 36.3. Our tolerance here is 0.0156, which is this one. Then we have an allowance which we got from our fundamental deviation as 8.7, or you can say minus 8.7. Then for our hole, we don't have a fundamental deviation, so it's 0. H is 0. Then our tolerance for our 0.39. Then our upper limit is 45.39. That's all for this example 1. So let's go to example 2. Example 2. We have 50 H6 and small liter H5. So our first step is our I. Step 1, I is equals to 0.45 D to the power of 1/3 plus 0.001 D. Then our D is equals to, if you check our chart, our diameter, they have to square both sides. If you look at the chart, you will know how we got the squares for the diameter, and by the time you square the both, you have 38.73. So our I is going to be 0.45 multiplied by 38.73 1/3 plus 0.001 multiplied by 38.73. So our I is going to be 1.56. So our diameter is 38.73. Then using the formula, when we insert it into this formula here, we are going to have 1.56 microns or 0.00156 millimicrons. So is if you are given, if your dimension, if your basic size dimension is given in microns, then you can work with this. If your basic size dimension is given in millimicrons, then you can work with this one. Our fundamental deviation for our hole, h is 0, and our shaft, h is also 0. Now for our IT grade, hole is equals IT grade 6. IT grade 6 is 10i. This is it. 50 H6 H5. So we have IT grade 6 and IT grade 5. IT grade 6 for our hole, IT grade 5 for our shaft. So it's going to be IT grade 6 and IT grade 5. So IT grade 6 is 10i on the chart. Then it's going to be 10 times 0.00156, which is for our I, which we got from our I, this one here. So it's going to be, our answer is 0.0156 millimicrons. So this is our tolerance for hole. Then for our shaft is IT grade 5. So it's going to be I7 if we check our chart again. It's going to be I7. So what we are going to have is 7 times 0.00156, same as this other one we did there. Then we are going to have 0.0109. So these are tolerance for our shaft. So these are tolerance for our shaft. So these are our diagram. For us to draw this diagram, we have to, our upper limit is have a basic size of 50. That is from here to this side is 50. Then our tolerance is 0.0156 for our hole, which is 0.0156. So these are our tolerance. By the time we add our basic size together with our tolerance, we are going to have 50.00156 millimicrons. So this is it. Then our lower limit for our hole, our lower limit, remember our h was 0. Our h here, look at it, 0. So it's going to be 50, which is 50 minus 0 is same as 50. So it's going to be 50 millimicrons. If there's any number here, it's going to subtract and it's going to turn to a bilateral tolerance. So our shaft here is it, our shaft, our upper limit for our shaft, which is here, is 50 minus 0. Our h is also 0. So it's going to be same as 50. Same as 50. Then our lower limit is 50 minus our tolerance for our tolerance for our shaft is our tolerance for our shaft. So it's going to be 50 minus 0.01, which is equals to 49.9 millimicrons. So that's for that. Let's go to number 3.